Before we talk about radicals, I want to talk about rational exponents for we'll talk about 3 scenarios. We'll talk about rational exponents, which are a type of radicals. We'll talk about 1 radical in the equation, and we'll talk about 2 radicals in the equation, okay? Before I start, though, if you saw a radical, let's say a 5th root, what would cancel that 5th root out? In other words, what's the opposite operation of a 5th root? The 5th power. Good job, Sam.
Dang,
okay, I know. Hadn't been here and got the answer right. All right. So the opposite there is whatever the root is, that exponent would cancel it out, right? What if I had, and I'm going to call this first scenario rational exponents. I'll give you a second to catch up. And then we'll talk about it. So if I have x to the 2/3, okay, we talked about the radicals and how we'd get rid of that. And exponent is really a different way to write a radical. How could we get rid of that 2/3 exponent?
I don't know.
All right, I heard cubed root it, and that would definitely work. Now, a cubed root is the same thing as what is an exponent? A third, 1/3 exponent. So that would take care of the 3, but then it would still leave the 2. Do what? Actually, not cubed root, because this is the same thing as the cubed root of x squared. So no, a cubed root wouldn't work, but what would work? You're going to have to essentially do 2 things. To get rid of this, you would do what? Of 3rd power. And to get rid of, I should do that in a different color. So to get rid of this, it would be a 3rd power on both sides. And to get rid of this, square root it. Do you agree that this side here could be written as 16 to the 3/2?
So you could.
So what's the relationship?
Right?
Correct. So what's the relationship? Look here.
Wouldn't the 3? So the 3 would be on the outside because it's underneath the shape.
Correct.
Of that, and then the 2 would be inside, and then why would you have? You would just put another 3 there as like an imaginary 3 to cancel out that one.
Well, what I added is what I circled here in purple and the green 3. That's what I added to both sides to get rid of what was or actually the radical, not the 2.
But isn't that by itself?
I wanted you, okay, before you get confused about everything, I wanted you to get to why it worked before I just told you what to do. But this is the reciprocal of this. So to cancel out...
All you gotta do is reciprocal.
So you just put the exponent on the other side and let it flip.
Correct.
So you get this?
So to cancel a rational exponent, raise it to the reciprocal.
I knew that.
If you think about it, it makes sense because a power to a power multiplies, and anytime you multiply something by its reciprocal, you get what? 1. So this becomes x to the first, which is just x, equals, well, what is 16 to 3/2? Oh, come on.
You do the little thing that we learned, like...
Square root of 16 to the 3rd. What is 16 to the 3/2? 64.
No, it's not.
Yes, it is. Yes, it is.
Degrees sensitive.
Let's do another example where I don't confuse you quite as bad.
I know.
Actually, solve it for x.
Wait, so you want us to do it by ourselves?
Yeah. Well, tell me what to do. We'll do this one together, then I'll give you one to do by yourself.
Divide by 7.
Divide by 7.
Oh, you divide by 7.
X equals 8.
8. Now what?
Multiply by 2. You do.
Well, raise it to its reciprocal. But yeah.
What lesson is multiplied by the reciprocal? I used to hear
So
that.
56 is part of the original equation. So
Correct.
it was originally 7x to the 3 to the 5th.
Let's finish this. I'm assuming you already finished it since you had so long.
No, we didn't.
All right, so 8 to the 5/3 is the third root of 8,
Which is 2.
and then raised to the 5th, which is 2, absolutely. And 2 to the 5th power is...
32.
Do you need a plus or minus sign here?
Yes. No.
Yes or no?
Yes.
Yes, no, yes. Which one?
Plus or minus.
No, why? It's an odd.
What?
It's an odd root. Odd roots keep the same sign. Even roots take a plus or minus. 32.
That makes me mad.
How about if it looks like this, can you still do it?
Wait, what was the answer of it?
I'm 32. Oh, don't. Yes. See what happens. See if you get. All right, what'd you do first?
I had one.
Add 1.
Exactly.
I distributed.
You,
Ew, you can't. It's
squared
just,
all by 4.
I don't know. I got confused.
listen to Sam.
Raise it to the 4/3.
Raise it to the 4/3. No, you're not. Remember, when you only see x in there one time, we can sad map our way out of it, regardless of what else is there. So I can 4/3 because parentheses are last. And that takes care of this exponent, which leaves me with x plus 2 equals, what is 8 to the 4/3? 2 to the 4th, because it's the cubed root of 8 to the 4th, which is 2 to the 4th, which is 16. Minus 2. Yay or nay? Nay? Where'd I lose you? You just don't like it. All right, let's talk about a radical. Okay, let's talk about radicals. Scenario 2. 1 radical. What you want to do when you only see 1 radical in the equation and you need to solve is always isolate that radical before you start solving. For example, y'all want to do an easy one or a hard one first?
Easy.
Hard.
Easy.
Hard.
Why would you start
You-
with hard?
Yeah, you start off easy so you can work on it. Oh, dang.
I'd rather just start off with a hard.
Yeah,
No.
but you don't know how to do it. It's harder to.
See, this is hard.
This is easy or hard?
Medium.
Well, that's
Alright, that makes sense.
Cut the difference. Is the radical isolated?
Yes.
Yes. Isolated means
By itself.
by itself. So I'm good to go to get rid of it. How do I get rid of that radical?
Square root.
Square. What? Square it.
Right?
Now, watch carefully. If I square this, I have to square this. But I'm squaring an entire side. Dun, dun, dun.
Yeah, I don't want to do
What happens on the left side?
2x.
X plus 1 times x plus 1.
Oh, yeah.
Do not distribute that exponent through there.
The 2 was the 2 just put on it?
Yes, the 2 was just put on it to make that go away. You said 2 and I wrote 2. So what do I do now?
I thought you would do.
So was the 2 on
Multiply it
the other side
out,
part of the
FOIL it
original
out.
equation?
The what?
The 2 on the
No.
other side?
No.
Okay.
I'll write this step by step.
Oh, what that is? Oh.
Yeah?
Y.
X times X.
2x.
I'm fixing to. But if I'd done 2x, everybody'd say, where'd that 2x come from? And I wanted you to see that it comes from when you multiply out and get your like terms together. Looks to me like we have some type of quadratic. Chapter 1.
This the one I hate.
Why? You don't even know what it's going to be like yet.
I said chapter 1. I hate that whole chapter except for the graphs.
We graph.
If you've got a quadratic, how do you solve it? What's my first step? What do I need to do? What is it? Well, but before I can use that, what do I have to do?
Make everything
equal 0. Set it equal to 0. So I need to move
Oh, I'm about to be fun.
and move. Move and move. I like to move
you
and
doing?
move it. I'm making it equal 0. X squared minus 5x minus 14 equals 0. Y'all like the way I said that? Can you roll your tongue? If I knew Spanish, I could probably speak it pretty
A,
well.
B, and C.
Because I can do it, yeah.
See, this quadratic form. I hate this, John. I don't even remember the form. Hold on.
All right.
Opposite b plus or minus square root of.
Opposite B.
Wait. Y'all are automatically jumping to the quadratic formula, and I say that's going to be my last resort, because what's easier than the quadratic formula? Factor it. Definitely factor it out. How does it factor, Shy? Make you so excited? How? What's it look like once you factor? There's no leading coefficient, so this is an easy factor. X minus 7, x plus 2. Easy peasy factor and an easy solve. Much easier, in fact, than the quadratic formula.
7.
Yeah, because I ain't doing the quadratic formula.
-2.
You will if it don't factor, unless you're going to complete the square each time.
That one easy.
Why are you asking me and I already taught you that? What you mean is it easier?
I forgot. What
Where you find a good C? The one where you find a good
I
C.
do remember that. I remember that.
Yes or no?
And the C is what is it, double or something like that, divided by 2? What's the C? How you get that?
B over 2 squared.
Oh, yeah.
All right. Now we'll make it hard.
Oh.
Y'all got this?
The hard one is going to be the quadratic formula problem.
Maybe.
I hate the quadratic formula.
Last one. 2 radicals. One on either side. Then get rid of one.
You going to do another project in the class?
Yeah.
When?
Well, I don't know.
It's going to be a group project?
Yeah, when we get to growth and decay, you'll do the
That. We do graphs.
That's been
It's a song. Oh, you talking about
That looks
this?
like so much fun. I really want to do that.
Oh, man, we're going to do this.
This is hard.
Want to do the project?
for this one's gonna be fun. You ready?
Is it really fun? Actually?
Yeah. It's math. Math is always fun.
No,
Nothing to lift your spirits like some good old math work. For me, anyway. All right. Do I have one radical on each side?
Yeah.
Y'all are fixing to love this. No. All right. One on either side. Get rid of one of them. Now watch what happens.
How you get rid of that?
How do you get rid of a square root? Square. I got to square this side, and I have to square this side.
What the one going to do?
Now, we just determined when you square something with a plus or a minus in the middle, you have to do what? Write it out 2 times. Y'all have, yes, I was gonna say you haven't seen it yet because nobody's saying anything. Watch what this looks like. Square root of x plus 2 plus 1 times square root of x plus 2 plus 1 equals, this is gone, 3 minus x. Remember how we had double PRZ problems? Yes, Miss McGee, we do.
Yes.
Wait.
Sometimes we have double radical problems too. Well, watch what happens. The square root of x plus 2 times the square root of x plus 2 is x plus 2. Multiplied by itself, both of them under a radical is x plus 2. Square root of x plus 2,
Right?
yes, times 1,
Root of x plus 2.
square root of x plus 2.
What?
Oh, what?
Now take this one. 1 times the square root of x plus 2.
Huh? I said you.
X plus 2.
And 1 times 1.
I'm tweaking.
Subtract 1.
Now, first of all, notice something here. These look exactly alike. Do you agree?
Yeah.
So what I'm going to say that I have is an x here. 1 and 2 makes 3. And I'm going to say that I have 2 root x plus 2's. Do you agree with that logic?
Yeah.
No, because you're adding, not multiplying. Remember when we did like radicals? If they had the same number under the radical and the same root, you could combine the coefficients in front. Okay. Now I have an equation with one radical. If you ever have an equation with one radical, what do? Isolate it. So like a double PRZ, this is a double radical kind of thing. I'm going to subtract 3. I'm going to subtract x. Oh, this is nice.
Yeah.
Okay.
Where'd you get 3?
I subtracted everything from this side. I'm trying to get the radical by itself. Still something hooked to the radical.
Wait, how did you get negative 2x?
Negative x minus x.
I thought you'd do plus that.
I had to subtract it from over here. So whenever I subtracted it, I moved it to the right side.
I hate this.
It's so much fun.
No, it's not.
It's McGee.
Don't be a party pooper, Shami. It's
I
fun.
thought that was x plus 2.
Where?
But you put x plus 3.
Not fun.
I combined, there was a 1 on the end here and there was a 2 here, so I combined them to make 3. I want to make sure everybody's with me before I go to the next step. Yes?
No.
Okay, what?
Give me
Okay,
2 seconds.
okay.
Pull up with a stick.
You want me to pause? Something is still hooked to the radical. What is that something? 2. What is negative 2x divided by 2? Negative x, right, Shami? The radical is now isolated. How do I get rid of the radical? Square it. Square it. X plus 2 equals x squared. I now have some form of a quadratic.
Subtract x.
Good job. And subtract 2. Why are we subtracting both of those?
Going negative,
Leading coefficient. Yep. And I want it to equal 0. Again, I'm to the point now.
When I say x to the second minus
X squared minus x minus 2. I love this
We'll
problem.
get back 2 seconds.
Yes.
Okay, so the x plus 3 up there.
How did you get squared?
Whoa! Okay, the x plus 3 back at the beginning of the problem.
Are you subtracting that from the left side?
Yes.
not the right.
No, I'm.
Okay, that's why I was
Plus 2
confused.
squared.
Okay. All right, so now I'm to the point where this, I need to solve for x. Again, you could use Shamique's favorite quadratic formula, or you could do like the rest of us who like it easier.
How do you square root? Why did you square root the x plus 2? Right there.
Here,
Yes.
I didn't square root it, I squared it.
How did you square it?
I put 2 there. What do you mean, how did I square it? The opposite of a square root is a squared. It makes these cancel. So because I put it here, I also had to put it here.
You square it.
I know, you just put it too. Okay.
Okay.
What are my solutions? -1 and +2. Circle it.
Circle it.
Sarah.
You're in a whole other land over there, Tanner. You're not even, you just circle it. Just circle it.
I don't even know what you did.
Me neither.
Okay, let's do another one.
Oh, wait, I was the right.
No, let's start the homework. Let's start the homework.
Right?
Cause you said this is one of the hard ones. That means we don't have that many hard ones on the homework. Yeah, so let's just go ahead and start the homework.
Y'all understand what y'all are asking for.
Homework. Homework.